IP networking is all done in routers. Routers connect the subnets to form the network. All right. So I'm just going to draw a nice, lovely picture here. Let's say, I'm just going to draw two actually. So we've got a company here, and this is like headquarters. They might have several subnets, okay? That means switches. So we have switch networks, and we might have, even with a core switch, right? So we did this in our VLANs one, remember that? So we have these several switches, and let's put another set down here. So we got another switch down here, another switch network here. So we might have several subnets down here. Let's put another switch here. And what I need is a router that's going to glue them together. Okay, the router will have a connection into each subnet. This is a terrible pen. I will throw that one away. So the router is going to glue together these different subnets. All right. Furthermore, there might be carrier connections, right? So I may have a site, a remote site somewhere. They're going to have their own switch. They might also have a router. Oops, I should write that in orange. I'm going to change this to orange. And then here I might have a WAN link. Okay?
Got a good green pen you want?
I got a green one too.
All right.
I'm all right with green. I got a blue one also. For now we're using orange, or we'll use this orange. I may also connect to my ISP. Okay? The people that are going to give me my internet connection. And so again here, you know, there's going to be another WAN link. If I'm using Cox, right, I have to lease, you know, some sort of, there has to be a coaxial cable running here. I'm going to have to get some sort of connection from them. They're also going to have a router, and they'll have their own subnets inside. So there will be different customers that are connected in here, but we don't know what's going on necessarily inside the ISP. All right? So that's that. I'm going to have to draw a bigger picture, sorry. Let me go back here, and let's draw. This will be the actual, well, let me draw it here. It's going to get dicey anyway. All right, so what the subnet is I'm going to manipulate these numbers on my IP address range. So if I was ODU, remember this part is fixed. The first 32 bits is fixed. I get to do whatever I want with the last 32 bits. I can subnet it, which means I can have a certain amount here to indicate, for example, the constant hall would be 212. I don't know what it is in this building. I'm not going to look it up, though. It's probably a different number. Well, maybe I should. I'll look it up pretty quick. Except, you know what? It might not let me. So, just like ODU, let's imagine our company here has divided their network into several subnets. So this might be 172.30.19.x. What that means when I write that is all the hosts are going to have these first 24 bits in their IP address. They'll be the same. The last part, this is the host part, the .x, will be unique for each host. Okay? So there might be somebody that's a .1, somebody into 19.2, 19.3, 19.4. You guys following me here? So that's one subnet. Let me look really quickly. What is my IP address? And I'm sure you're all wondering, but my IP address in this room right now is 128.82.42.165. Okay, this is in Gornto 205. In case you'd like to come by, some of you out on the internet can come and visit us between 1 and 3:30. But notice here, 128.82, that first part's the same. The 42 means we're in Goronto, where the 212 meant it was in Constant Hall. The 165 is this computer I'm sitting at. In the next room over, or in the control room, there might be other computers in here. They would have, 166, 167, etc. So that's fun. This is nice. All right, so this company, again, they are 172.30, okay? And they're manipulating these last 2 octets. So I've got another subnet down here, 172.30.20. .x. Oops, I have to put the x in, right? I have another one, 172.30.21.x. And then up here we'll put 172.30.22.x. And I'm sure you all are used to, from systems analysis, of drawing diagrams that don't actually represent. This is a logical design. You guys following me here? Okay. We dealt with physical design before, where we were actually measuring the length of cables. We're not doing that here. So this is a logical design of our network. Notice again, 172.30 is the same. Each subnet has a different subnet referencing it. Okay? Now these are all going to connect into a router. I'm going to draw my router here. And a router will just have its ports the same as a switch. And we're going to put 19 into port 1. We're going to put 20 into port 2. 21 goes into port 3. And 22 goes into port 4. Okay? So that's a lovely thing. And I want to remind you here, these subnets, remember, there's a switch in here, right? And lots of hosts connected to it. So if we drew that in here, it would be lots of hosts connected to switches, and then this router is connected into that switch network also. Are we good with this kind of stuff? This is easy stuff, right? All right, so there's part of our router. This router, by the way, would be called an internal router. Okay? Because it's inside our company network. Let me get this marker off. So I've learned the hard way that you got to get the marker off right away. So there's a little spot. No, you guys can't see it. All right, so that's an internal router. I might connect here to another site. And this site is going to be 172.30.23x. So this is a remote site. And I'll just note here, I'm going to have plugs. This is another router. Okay. Actually, this router would probably be over here. I should have drawn it over there. That's okay. I'm also going to have an internet connection. So there's going to be another router here that is going to connect me to my ISP. The ISP's overall network is 128.171. Okay. I connect in particular to a network that is 128.171. Oops, 171.17.x. Okay. So within my router's router's network, they'll have another router, and let's just say it eventually goes here. Right? So this is where it gets fun. So this was an internal router, internal within my company. These routers here between my company and the rest of the world is the edge. That makes sense? Sometimes you call it a border too. You call this either a border or an edge router. This again is the router that connects me to the rest of the world with the public network, with carriers. Okay? Internal is within me. The edge connects me out. Right? This is pretty normal stuff. ODU might have, well, the ODU does. They have a router like this. It connects various buildings on campus. They have other routers that might connect from here to, say, Virginia Beach. and then they have their internet connection too. And notice here I have another internet connection from my site. So my site has its own internet connection, plus we have a connection that we manage ourselves between the headquarters and the site.